Hi everyone! This is the second video related to the derivative. In the first video, we studied the derivative by using the tangent line slope and the rate of change in a function. Today, we are going to go deeper, studying the basic rules to derive any function. We defined the derivative of a function as another function that describes the rate at which a dependent variable changes with respect to an independent variable in the point x. If the function is f of x, the derivative is f prime of x equal to the limit when h approaches to 0 of f of x plus h minus f of x divided by h. To understand better the definition of the derivative, I am going to explain the basic rules by proving them using the definition. To derive a constant function, f of x equal to k, we will use the definition of the derivative and substitute the function equal to k in the definition. Since this function doesn't change with respect to x, the numerator is equal to 0, and the limit is also equal to 0. Therefore, the rule number 1 says that when a function of x is equal to a constant, the derivative of a function is a new function equal to 0. As an example, we are going to derive the function of f of x equal to pi first by using the definition. When we substitute the function equal to pi, the numerator is equal to 0 and the limit of 0 when h approaches to 0 is equal to 0, and the derivative is also 0. Now that we understand how the definition of the derivative works in this case, we can use the rule. Being the function a constant equal to pi and the derivative of a constant is equal to 0, if we represent this in a coordinate axis, we see that pi is a constant line that doesn't change with respect to the coordinate x. Therefore, the derivative represents the no change of the function. The next rule is the derivative of a power that can be obtained by using the definition of the derivative when the function of x is equal to x powered n. In previous videos, I have told you that with a lot of algebra, we get some result. But guys, this time I'm not lying. So sit tight and let's begin. The first step is to use the definition of the derivative and substitute the function. Then, if we power x plus h to n minus x power n, we have this expression. Then we have to factorize, dividing and multiplying by h. Now we can simplify, and then apply the limit when h approaches to 0. Finally, we have that the derivative of a power is the power number multiplied by x power n minus 1. These look a little bit scary, but you don't have to do this every time you want to know the derivative of a power function. You can use the rule. When f of x is equal to x power n, the derivative of this function is n times x power n minus 1. Let's solve an exercise, obtaining the derivative of the function of x equal to x power 4. First, using the definition of the derivative. We have to substitute x plus h in the function and then expand the product. After that, we can simplify. And then calculate the limit when h tends to 0. Finally, we get that the derivative of the function is 4 times x cubic. Now, we are going to prove that the rule works by substituting the function. In this case, n is equal to 4, and n minus 1 is equal to 3. Therefore, we prove that the rule can be used to any problem of this type. We can represent the function and its derivative in the coordinate axis, remembering that the derivative is also a function of x. Now I'm going to give you some other important rules without proving them. You already know how to prove a rule of the derivatives by using the definition. The first one is the constant multiple rule, that says that if you have a function multiplied by a constant, its derivative will be the constant multiplied by the derivative of that function. The second is a rule for the sum and difference of two functions f and g. In this case, the derivative of the sum or difference is the sum or difference of the derivatives. If we multiply two functions, the derivative of this product will be the first function multiplied by the derivative of the second plus the derivative of the first function multiplied by the second function. What would you do if you want to know the derivative of the multiplication of more than two functions? Tell us in the comments below. Finally, the quotient rule says that when we divide two functions, the derivative of this quotient is the derivative of the function in the numerator multiplied by the function in the denominator, minus the function in the numerator multiplied by the derivative of the function in the denominator, and all this divided by the square of the function in the denominator. Remember that a function can also be written as y equal to f of x, and the derivative of x prime of x can be represented as dy divided by dx, that represents the change in the variable y with respect of x. Wow, too much information in one video. I thank you for staying with me, and only because it's too many information, we will solve only one more exercise. If you thought it will be a quick, easy exercise, you were right. We are going to use all these rules to solve the next function. First, we are going to use the sum and difference rule. We can represent the derivative of the sum and difference of the terms in the function as the sum of each derivative. For the first term, we are going to use the constant multiple rule. And using the power rule, the derivative of x squared is 2 times x. Multiplying it by the constant 3, we get 6 times x, and that is the first term. In the second term, we have a multiplication, and using the rule of the product, substituting, derivating the terms, and simplifying, we obtain that the derivative is 6 times x squared minus 2x plus 4. And the third term, we are going to use the quotient rule, substitute the values, and simplify. We get that the derivative is x divided by the square of x plus 1. And finally, here is a graph of the operation that we just did. Being the darker line the function y, and the light blue line is the derivative of the function y. You don't have to do the graph of the derivative every time you solve one of these exercises, but doesn't look nice? I like showing you how maths are more than numbers, and I hope you enjoy it as much as I do. I'll leave you with all the rules that we studied today so you can take a screenshot and believe me when I tell you that you are going to use these formulas. If you haven't subscribed yet to the channel, this is the moment to do it, and if you like the video, let us know with your thumbs up. This is everything for today, and see you in the next video of the derivative of trigonometrical functions. Bye!
Hope you guys liked this video. To make your math geek happy, subscribe to our channel, and I'll see you later.